Today we want to spend a lesson focusing on differentiating equations that have negative powers. It works the same as the other differentiating that we've been doing. If I want to differentiate something in the form y equals kx to the power of n, the derivative dy over dx, the n comes down the front and multiplies with the k, x is the base, and we subtract 1 from the power. You just need to be extra careful because there's going to be more negative signs about. It says if x is in the denominator, you may need to do some rearranging first. Okay, so for question number 1, A here, to differentiate, I'm going to do dy over dx. The negative 3 comes down the front and times is with the negative 2 to make a positive 6. X is the base and you subtract 1 from the power. Now subtracting 1 takes me to negative 4. And that's it. Let's do B. So because this is in fraction form, before I differentiate it, I need to rewrite that by bringing the x squared up, and that would mean it will become a power of negative 2. So then I can differentiate dy over dx equals, bring the negative 2 down the front and times with the 3. That makes negative 6. X, subtract 1 from the power, makes negative 3. Now I want you to always get into the habit of trying to leave your answer in the same form as your question. So because my question was in fraction form here with positive indices, I'm going to change my answer back into fraction form. So that will be negative 6 over x to the positive power of 3. Part C. Again, I have fractions in here with x's on the denominator. So before I can differentiate, I have to bring that x out to have a negative power. It'll be negative 1/4 for the number in front and x to the negative 6. Now I can differentiate, so dy over dx, or you could be using y dash notation if you prefer. Minus 6 times is with the minus 1/4 to be a positive 3 over 2. X is the base, subtract 1 from the power makes minus 7. To put it back into fraction form, the 3 is on the top, the 2 is on the bottom. The negative power of x here, we're going to move that to the bottom to be x to a positive power of 7. And that's it. Part D. When I have 2 terms on the bottom of the fraction, to rearrange that, you want to put the 3 minus x squared in brackets, and the whole thing would be to a power of negative 1. So then I can differentiate that using my shortcut chain rule method, which is to bring the negative 1 power to the front, multiply by the derivative of the bracket, which will be from the minus x squared term here. I'll bring the 2 down, so become minus 2x, and then you multiply that by the bracket and subtract 1 from the power, which becomes minus 2. So minus 1 times minus 2x becomes a positive 2x. The bracket here with a negative power of 2 is going to go to the bottom of the fraction, 3 minus x squared with a positive power of 2. Part E. There's only one x term on the bottom, but because there's 2 terms on the top, what I want to do is split the fraction apart. I want to do 4 divided by x cubed minus the 2x, also divided by the x cubed. That means I can simplify each term. So for the first one, 4 and the x cubed, I could write that as 4x to the negative 3. For the second term, I could cancel the x on the top with one of the ones on the bottom, so I have x squared on the bottom, and that would become minus 2x to the minus 2, getting rid of all the fractions. So now I can differentiate. So I'm ready to do my dy over dx, or this time I'm going to use my y dash notation. So bring the power down the front. Minus 3 times 4 makes negative 12. X, and subtract 1 from the power makes negative 4. Now for the second term, minus 2 times minus 2 makes plus 4. X, subtract 1 from the power is negative 3. Now we can turn those back into positive indices by putting them back on the bottom. So minus 12 over x to the 4 plus 4 over x to the positive power of 3. But also in the question, I only had one fraction. So it would be nice if I could get a common denominator and push those together. So I have x to the power of 4 and x to the power of 3. The common denominator would be x to the power of 4. The first fraction already has that, and all I need to do is multiply that second fraction by x, which means I would have a 4x on the top. And that is it. One last question, f. So I have 3 terms on the top of the fraction, so I'm going to split this into 3 terms. So 3 over x squared minus x squared over x squared plus 4x to the 4 over x squared. Now the first term could be rewritten as 3x to the negative 2. The second term, x squared over x squared, would cancel out and I would just have negative 1. And the final term, x squared on the bottom, would cancel with 2 of those, and I would just have a positive 4x squared. Now that all my fractions are taken care of, I can differentiate dy over dx. Bring the negative power down to the front and times with the 3, so that's minus 6x. Subtract 1 from the power is minus 3. From the minus 1 is a constant term, so that's going to disappear. And the last term, again, bring the power down to the front. 2 times 4 is 8, and x to the power of 1. I can rewrite that so that I have positive powers. That means the x cubed would come to the bottom. And then I could get a common denominator, which means the x cubed would have to go over everything. I have a minus 6 already from that first fraction. The second one I would have to times by x cubed, which would be 8x to the power of